Happy to start the second day, and actually the last day of the conference. My name is Amir Zmora from FlexiWAN, and the first session of 3 presentations is going to be service provider openings. And the first speaker is Professor David Hay, who is a Chief Security Officer at BBT Live, and also the head of Cyber Research Center at the Hebrew University in Jerusalem. Over to you, David.
So thank Amir for the introduction, and I came from BBT Live, which is a rather new and small company in the SD-WAN arena. So let me, because I'm the first speaker of today, of the service provider day, let me start with 4 use cases that we have with our customers here in BBT facing ISPs or MSPs or other service provider. What did they do wrong? They say this microphone works as well.
You cannot use the hand microphone.
Yeah.
You're moving around.
Yeah, so I'll try to stay fixed. It might be problematic, but
You can use the hand microphone.
yeah, that's even more problematic. Yeah, so our first use case is an apparel retailer. So we got an approach by an ISP that has a very large customer that sells apparel across malls in the country, and it needs to provide some connectivity across all the malls, all the branches. And the connectivity is needed for cash registers, voice over IP, and some video streaming or video cameras that they are streaming on the screen, some commercials and stuff across the branches. So when we approach this ISP, we provide it our solution, and we got 20 times improvement in speed. We solved this poor coverage that was extremely dominant in these malls. We reduced the number of appliances that this apparel retailer had from 3 to only 1. We reduced the point of failure. We broke the vendor lock-in because our architecture is tech agnostic, which this will be the focus of the talk, and I will go in about it just in a few minutes. We saved the OPEX and CAPEX both for the ISP and the retailer, and because this was a very large chain, so we had to provide zero-touch deployment. So because we had to deploy all these appliances or all our network at once, and when new branches come in, we need to deploy more and more. And the key issue that was needed both by the CSP and by the customer was management and visibility. So they want a single dashboard that manages everything and see everything, and this is exactly what we provided.
David, I want to stop you for a second, because
I'm going to that one?
They're streaming it so people cannot hear you.
Oh,
Those are online.
so yeah, now can you? Yeah, so now I'm feeling like a singer from the 80s, but okay. So that was management and visibility, and the network was managed not by the ISP, but by this customer, by the apparel retailer itself. So if it wants to add more cash registers or more branches and so on, so it was able to do so. The second use case is quite different. It was an MSP, not an ISP, that approached to us, and its customer provide airport entertainment. So it has all the screens in the airport that broadcast video, either live streaming like news and stuff, or a video on demand that was pre-recorded before. And it had to manage all these screens in the tens or even hundreds of airports across the country. So this airport entertainer doesn't really care about network, so it doesn't manage anything. So the MSP is doing everything for it, unlike the apparel retailer. And the content is very, very specific. It's this live video and live streaming. So here what we provided is improvement in speed, latency, and stability. There is poor coverage in airports. You're probably all aware of that. So we solved this poor coverage, not in all airports, some airports. We reduced the number of appliances. We reduced the point of failure. We saved the OPEX and CAPEX as before. We provide zero-touch deployment. It's a large network, and provide management and visibility as before. So the third use cases, I have only 4, don't worry, it's not going to be very long, was completely, it was something not with an MSP, but it was a public safety agency that approached us, and they need to provide connectivity for IoT devices that are either fixed or mobile, but the key issue was they are in very, very remote area, almost no coverage, and they are across national border. So even if one IoT can be in one nation and another IoT can be in another nation, and they need to be managed together to deliver data back and forth between the nations and so on. And for that, we provide our solution, and we use the fact that we are SD-WAN and we can aggregate WAN links and so on. So we solve this extremely poor coverage. This is one of the key benefits that SD-WAN in general and BBT Live in particular have advantages over traditional LANs. We reduce the point of failure. We save OpEx and CapEx as before. We provide zero-touch deployment because these IoT devices come and go, and sometimes we are not aware of what's going to be to happen because we left this public safety agency not by itself, but they manage their own network and provide management and visibility as before. And the last, and perhaps this is the most important use case that we have, or the stuff that this is like our more of target audience, is an MSP and ISP, an MSP that wants to buy our services and sell it to its customer, and we are just selling it to the MSP, and then it sells to customers that we don't know of. We don't know, and the MSP wants to know a priori what the customer will be. So, therefore, when you say connectivity for, it's not connectivity for something specific, it can be for everything, because we don't really know what will be the end customer. So in this case, some of the end customers were known before, some of them was the MSP itself, so it has stores, so it was in its store, but in general, we didn't know. And one of the demands that we got is to use existing hardware. It's not to use hardware that we are bringing, but this MSP has some servers somewhere in the stores or in customers, and it wants to install our software or SD-WAN software to manage the network in kind of a virtual machine. So here, actually, we reduced the number of appliances from 3 to even 0, because we didn't install any appliance. We just ran software over existing hardware. And again, as I said before, all the stuff holds. So the benefits of BBT solutions and for SD-WAN in general to the service provider are quite apparent. I think that everyone here in the audience know that. We prevent churn of customer between different providers. We solve the poor coverage of remote areas or malls and stuff like that. Zero-touch deployment is very important because there is a massive amount of network devices that need to be deployed, sometimes at once. Management and visibility, which is very important to our customers. Lowering the cost, which is always good. And reduced time to market, which is always good as well. So in order to do that, what I argue is that software-defined connectivity or software-defined network must be tech agnostic. And by tech agnostic, I mean it in 4 different aspects. The first one is being hardware agnostic. The second one is being cloud agnostic or agnostic to the cloud provider or the type of cloud. One link agnostic, so we can work on any one link, and service vendor agnostic. So let me quickly, I'm just seeing if I'm running out of time. No, I'm okay. So let me quickly go over all these aspects of being agnostic and into more details and see what is the service provider benefits of doing so. So the first one is being hardware agnostic. So I think this is maybe the most important thing that we have in BBT, and this is what our customer really wants. So our software, and I think that any SD-WAN software should work with software disaggregation and should work on any or almost any existing hardware. So it can work on Xeon servers, it can work on Atom. We can have PC as a CPE. We can work on SmartNICs or data processing Unix. This is the NVIDIA name for SmartNIC these days, or dedicated box. So we have deals with all, this kind of dedicated box vendors. We are working with NVIDIA, but we can install on any server. And as I said before, in the fourth use case, we can even be installed as a virtual machine on top of existing hypervisor. And if we need to go, we have some collaboration that we are installed on ARM and not just x86. And this, means that the hardware determines the performance. So you cannot expect a Xeon and Atom to behave the same. So the hardware depends the performance. The software is the one that determines the functionality and the manageability and the visibility. Orchestration and control, this is typical to SDN in general and the SD-WAN in particular, are separated. So we have data plane like this. On top of that, we have a control plane that is done someplace else where the orchestration is done and so on. And because we are hardware agnostic, we can move computation and we can move tasks between different components of the network. So if, for example, a packet goes along some path, so we can do DPI in the first point of entry or somewhere upstream. Depends of which hardware is running. We can detect it online and just can move around the stuff. It's more challenging than it looks, but it's doable. And the service provider benefits for that is that it eliminates the vendor lock-in because it can work on any hardware. It lowers the cost because you can choose the really right hardware for your customer. It provides flexibility and lower time to the market. I actually talked with Brianna yesterday that, about COVID stuff, that no hardware or no specific hardware can be found. And now because we are hardware agnostic, so we can use early hardware. This hardware is not available right now because of a crisis. We can use another hardware. That helps us a lot, and this is really important in this pre-post-COVID era. Cloud agnostic. So this is the second aspect of being tech agnostic, is to be agnostic to the cloud provider. So we can work with any cloud provider. It doesn't matter which one. This depends on the cost. This depends on the latency or if you have, like, for example, point of presence close by to a specific branch, so we can connect with this cloud provider. Our cloud provider can be either private or public. We can host, and we do host some of the cloud components of our solution. And that means that we can support mobile edge computing, and we can support the new future, I think, of SD-WAN, of bringing IoT to the 5G, 4G, bringing SD-WAN to the IoT or to the 5G, 4G era. What's really important is because we are cloud vendor agnostic, so we can, this is like a multi-cloud solution. So we have customers that several of their branches are in one cloud and several branches in their other cloud, and we connect them together in a multi-cloud environment. And this means, architectural-wise, that we are cloud native. So if we are speaking about the Kubernetes lingo, so this means that this is a multi-cluster Kubernetes deployment. We are incorporating with other multi-cloud connectivity solutions. So because we are a multi-cloud solution, so sometimes we are doing it by ourselves, and sometimes we can collaborate with other solutions that are out there. So this is actually eliminate cloud vendor locking, reduce the cost flexibility. We provide access to new market segments, like, as I mentioned, the IoT 5G, and we get top performance because we can choose the right cloud for you. The third aspect is one connectivity agnostic. That means that we can work from the branch or from the CPE or from the premises to the cloud. We can work with any one technology. So it can be any broadband, like 4G, 5G, MPLS, VDSL, fiber, whatever you throw on us, we can deal with. We actually create, if there is multiple links living in one premise, we bundle them together and we create an overlay network of our on top of these physical links. We invested a lot in this algorithmics of dynamically steering the right application to the right links, detecting the links properties and reacting to them. So we provide per session bonding or per packet bonding, or in case of failover, we can quickly move from one link to the other, and that this is it's easier said than done, but we invested a lot in this algorithmic approach to that. What is really important is that we need to secure this link, so we don't trust that these links are secure a priori. So we provide either our own security or collaboration with third party like Checkpoint and Rode Schwartz in order to secure the links between the CPE and the cloud gateway. So, so I think this is quite obvious that if you have this one link agnostic and you can use any one link and you can use several one links in one point, so you can serve poor coverage areas. This is what we did with the public safety. We can increase the bandwidth because we use this aggregated links efficiently. We reduce the cost because we can choose the most economical way to move the packets in any time. We provide flexibility, new opportunities, for example, this case about the IoT, and increase the performance overall. And the last aspect of being 4 minutes. So the last aspect of being service vendor agnostic is that we can incorporate with any third party. So we can, over our network, we can cooperate with any security provider, deep packet inspection, voice over IP and video. This is done using VNF and CNF API, so usually with very, very low to zero integration. We provide one-click insertion, and that gives the flexibility of deploying it everywhere in the network. So if you want to do it in the branch, you can do it. If you want to do it in the cloud, you can do it. We provide everything. And this, again, eliminates vendor locking, but also provide some enterprises or some customers that already have legacy deployment to stay with their legacy deployment while using our SD-WAN solution. Reduce cost, flexibility, and simplify new service deployment. So in order to do all that, and that I will be very quick because I have only 3 minutes left, so we took some architectural choices. So I listed here 4 of them. So one of them is that we have one unified software, which we call the XGW, X for everything and GW gateway, that manage all our network components, switches and all other network components. I will just show you a diagram in the next slide. The other one is that we are a cloud native, so we have a multi-cluster cloud native architecture, which I won't go over it. We have this bonding mechanism that I mentioned, but I won't go over it, and on-the-fly service insertion that we provide. So just the XGW, so we treat all the network component like that, like as a unified software that is really the same software but deployed in different places. So on one side, you have the upstream links. On the other side, you have the downstream link. Our customers demanded internet breakout, so you can internet breakout. You can break out to the internet from the device. And we have link APIs to the orchestrator and APIs to the VNF and CNF in order to provide more services. What's really important with the XGW is that security-wise is that the XGW is our software and it must be secure as well. So here we collaborate with Checkpoint or Checkpoint Protect to protect. So it's not protecting the traffic that go through the XGW, but protects the XGW itself. So we are not where people can attack the network. And what we do with this XGW, so we have this Lego piece, and we can provide overlay network over these pieces in a holistic flat architecture, which I think most of the other stuff I said before. So the XGW can be deployed as a CPE, we call it local gateway, LGW. So on one side, you have the WAN links that are bonded together. On the other side, you have the local area network. It can be deployed as a cloud gateway. So this is the other side that connect from the LGW. So here at the downstream link are the WAN links, and the upstream link is the LAN between cloud gateways. But it can also be deployed as within the specific LAN, so we call it internal gateway. So that's why we get visibility inside the LAN, or not just between on the WAN. So we can deploy it within the LAN as internal gateway, even a single host, because this is a software that is very, very lightweight. So we can deploy it on a single PC or a single host if you want to work from your hub. So we call it a host gateway. And if we want to, for the multi-cloud purpose, we have also zone gateway, but it's the same functionality for everything. So because I have only 1 minute, so this is the block diagram that we have. It looks in a way very similar to other SD-WAN components. We have some differences, but you are welcome to our booth, which is just when you exit the door on the left-hand side. I can explain more about that. We provide connectivity, security, and ZTNA, visibility, including inside the LAN, and routing and switching. And the benefits of, and this is the last slide, of using a BBT tech-agnostic solution is that we get, it's very easy to use, it's easy to deploy, it's scalable, cost-effective, secure, reliable, it provides high performance, and because the flat cloud-native architecture, we can monitor the entire network, even within the LAN. It easily scales, as I said before, and we have this a lot of work about defining user profiles in order to explicitly expose what each user in the network can see or cannot see. Tech agnostic, and this is the last sentence and I'm leaving. Tech agnostic makes cooperation very easy. So we have cooperation either with the hardware, because we can work on any hardware. So we have cooperation with hardware vendors like Advantech, Dell, Intel, and NVIDIA, and with service provider like Checkpoint and Rohde Schwarz. Thank you. Thanks a lot.
Okay. Next.